The brain implant that turns signals into speech. Scientists have invented an implant that can turn brain signals into electronic speech. The implant, developed by University of California research scientists, aims to give people who have lost the ability to speak a better way of communicating than current methods. The brain implant was created to read and record brain signals that help control speech-producing muscles, which includes the lips, larynx, tongue, and jaw. The study made use of a two-step method experiment. First, the researchers used a decoder to turn electrical brain signals into representations of human vocal movements. A synthesizer then turns the representations into spoken sentences. Lead researcher Edward Chang reported that the new two-step method presents a proof of principle with great possibilities for real-time communication in the future. Chang added that this pioneering study demonstrates how an individual's brain activity can generate entire spoken sentences. The study involved 5 volunteer patients who were being treated for epilepsy. The individuals had the ability to speak and already had electrodes implanted in their brains. The volunteers were asked to read several hundred sentences aloud while the researchers recorded their brain activity. The researchers used audio recordings of the voice readings to reproduce the vocal muscle movements needed to produce human speech. This process permitted the scientists to create a realistic virtual voice for each individual, controlled by their brain activity. The study reports that the spoken sentences were understandable to hundreds of human listeners asked to write out what they heard. The listeners were able to write out 43% of sentences with perfect accuracy. The researchers noted that, as is the case with natural speech, listeners had the highest success rate identifying shorter sentences. The team also reported more success synthesizing slower speech sounds like sh, and less success with harder sounds like b or p. The researchers admitted that much more research of the system will be needed to reach the goal of perfectly producing spoken language. Future studies should also be undertaken to test the technology on people who are unable to speak. However, while other brain-computer interfaces already exist to help people who cannot speak on their own, often these systems are trained to follow eye or facial movements of people who have learned to spell out their thoughts letter by letter. But researchers say this method can produce many errors and is very slow, permitting at most about 10 spoken words per minute, compared to about 100 to 150 words per minute used in natural speech.